So what are the odds that this is the only place that people would be talking as we are?
Welcome to the edge of nowhere. Hello and welcome everybody to this 34th episode of the Monster Lore Tour Paranormal Deep Dives from the Edge of Nowhere podcast. I'm your host, Jeremy Carr, here along with my co-host and the Chekhov to my Sulu, Mr. Matt Ozero, aka the MOZ. How we doing today, MOZ?
That works. I navigate, you'll helm.
Yeah, we're not in it for the fame and fortune. We're just here to find the way.
We do overact, though, but you're right. I think it's more Chekhov.
Did you like how I did my all right to the Star Trek theme song? Did you hear that?
No.
All right.
Oh, that's what that was.
Huh? Yeah.
I get it now. Yeah. Very over of you.
Yeah. Yeah.
She did that at the ending. That was her voice.
Yeah. Today we have a very cool interview. We're skipping old business. We don't do old business on the interview episodes. But today we have an interview with a real-life astrophysicist. Dr. W. David Arnett will be discussing a variety of topics with Dr. Arnett, including the nuclear bomb, the science of supernovae, dark matter and shape-shifting molecules. You got to like that one, Moz. Yeah. And Arnett's Law, which was created by Dr. Arnett himself, as well.
So that's not just a coincidence.
As well as the importance of Star Trek references.
Yes.
Which is why we opened that way.
Mm-hmm.
About the first half or so of the interview is Dr. Arnett's history and some breakdown of the science he has studied. Gets pretty cool in there. That supernovae stuff is quite monstrous in its way. The second half is when we get into our more theoretical side of the discussion, and in pure MLT fashion, it just gets weirder as we go at that point. And we do get a big shout out to Neil deGrasse Tyson from Dr. Arnett as well, which is pretty cool. But I don't want to give it all away, so we're going to get into it pretty quick here. But you ran the interview, Moz, pretty much. So is there anything you would like to add before we jump into it?
Let's jump into it.
Let's jump into it. With that, here is our interview with Dr. W. David Arnett.
Hey everyone, so we are here with astrophysicist and author Dr. William David Arnett, aka Dave, who appeared in National Geographic, winner of the Hans Bethe Prize for his outstanding work in theory. And if that's not enough, you have your own law named after you as well, Arnett's Law, which I'm sure we will break by the end of this podcast. And if that's not enough, he got a Lifetime Achievement Award from the American Astronomical Society in 2012. And he's a 5-time returning Jeopardy champion. I just added that one, but it seems like you need a little bit more. Actually, we can't get through all your accolades. You have way too many. But did I miss anything? There's other major things, I'm sure. You have an honorary degree.
Yes, several.
So tell us about those, maybe. Where do you have honorary degrees?
Well, the one that I like the best is from my alma mater, the University of Kentucky.
Nice. Because you never really graduated the first time, and they were like, hey, this guy's okay.
Yeah, I went through fairly fast.
Gotcha. So you were so fast you didn't get a degree. Oh, you were never really there long enough to get a degree.
I was there, and I had the advantage of an undergraduate riotous career.
Nice.
I wasn't very riotous because I wasn't very old at the time, but I did my best.
But we can actually I call people rock stars all the time, but you literally study space rocks and stars.
That's right.
If you studied Ziggy Stardust, that would be even cooler. But, probably. Are you a Bowie fan? Because we could stop the interview. Okay, we'll keep going then. You also voted on the planetary status of Pluto, I understand.
I was there for the meeting.
Oh, you didn't vote?
Yes, I did vote, but it didn't make a difference.
Gotcha. Well, what did you vote?
It doesn't really matter what you call it.
Mm-hmm. Okay.
I mean, it may disappoint a lot of young students who've carefully remembered all the names of all the planets, and now one's not a planet anymore.
Yeah, so what do I do with that piece of information? Do I just send it out to the Oort cloud? Or?
Well, that's where it is, because there are things out in the Oort cloud which are as big as Pluto.
So even my joke is wrong because it was already there. Is that what you're saying?
Yeah.
This is going well.
Some days are like that. That's what chaos theory is about.
I'm going to just read into that and say a nay vote for planetary status. So does Percival Lowell just break stuff at your house at night? Does he come and haunt you?
His ghost does.
Because we can help with that. We can actually help. That's kind of what we do. So if you have any trouble in that line. But we actually set an egg timer today. As soon as we make Einstein look like an idiot, we're going to mark that little time and just stop the egg timer.
If we can do it, let's go.
So what other pieces of your career would you like to talk about? Because that's just a wiki memories kind of moment.
Well, it was a big change when I went east from Lexington, the Kentucky Lexington.
Mm-hmm. Not the Massachusetts.
No. My wife's from the Massachusetts.
Well, that's weird. But okay.
That is. That was not one of her really enticing attributes, however.
It's like a Hatfield and McCoy moment almost, huh?
Yeah. She had ancestors that were on the Mayflower. Her father said the damn boat would have sunk because it had so many ancestors that were on the Mayflower.
Dang.
And I had ancestors who went across the Alleghenies with Daniel Boone. So, the opposite ends of American culture at that time.
So we asked him about his career, and we're talking about the Alamo. Okay.
Yeah.
We went back a little ways. What about what you've done other cool stuff, I know you have, you did with your career.
I think the thing that I'm happiest about, or one of the things that I'm happiest about, was figuring out the blueprint of the elements.
Yeah, and we'll get to that. If it's going to be in your book there.
Which is in the book.
Yeah, we'll definitely get to that. Maybe is there other things you were involved with? Like, we always want to know about Area 51. I know you're too young for the Philadelphia experiment, but did you have any intel on any of that stuff? I mean, you can say it.
Well, I remember when I plotted up the light curves from my supernova model, and they worked incredibly well.
Wow.
I was just too lucky to that. It's like winning the sweepstakes.
Yeah.
And I was thinking, my God, the universe, it's talking to me.
Awesome.
Mm-hmm. I tried the key in the lock and it opened.
Yeah, everything checked out.
Everything checked out.
But other projects you might have been involved with, or things that we want to mention? Or
I did a lot of advising for Los Alamos and Livermore. And
like
that I can't talk about.
The Manhattan Project stuff?
I knew most of the members.
But you weren't part of the Manhattan.
I was not part of I was too young.
Oh. So you were like part of the New Amsterdam Project. Yeah.
Yeah, must have been.
No, that's awesome. So you were advising for some big things that you can't talk about.
At the time, I couldn't talk about. Now they're dated, so it probably wouldn't matter, and I don't even remember them that well. So it's not a big deal. But it was strange for a farm boy from western Kentucky to be in the middle of that.
Yeah.
It's
another moment in your career.
Right.
And you were young. This was the young part of your career.
Oh, I have almost always been the youngest member of a group, except now. So now I'm an emeritus professor, so I don't have that advantage of always being the youngest one who did this.
But you did run into some other big names at different times, I imagine.
You mentioned the Beta Prize, Hans Bethe.
Yes.
Who was instrumental in sort of one of the fathers of modern nuclear physics. And he was one of my heroes.
That's awesome.
And I met Chandrasekhar. He was a colleague at the University of Chicago later. And one of my projects was seeing what stars which are near the Chandrasekhar mass do. And at the time, we didn't know. At the time, we now think many of them become supernovae.
Wow. So your math helped to kind of unravel some of this, too.
Well, the math was the language.
Yeah.
And it was the key to the crossword puzzle. You know, the same way you look at a crossword puzzle and you try to match patterns. You know, is this part of that picture, or was this line going to be part of that line, and then join up the pieces? That's what the mathematics was doing.
So you found the math, and then the data trickles in, and at some point you're like, whoa, did it happen that way?
The data had already been there.
You're just messing
and
with
more trickled in later because we could ask
the right questions.
Much crisper questions.
Nice. But did you like hang with Copernicus or anything? Like, give us an area of the time.
I had the good fortune to visit Poland shortly after Solidarity, and I had worked on supernova, in particular stars near the Chandrasekhar mass, and a young Polish astronomer, Bogdan Paczynski, had been working on the same thing. And he was able to get out of the country and make a visiting tour of the Americas. And I was a postdoc at Caltech. And we headed off. So Bogdan gave me an insight to what Eastern Europe was like at the time.
Yeah, gotcha. And what was that? Do you want to share that insight?
Well, one thing that I remember that was particularly suggestive was going on a train from Warsaw to Krakow to a different venue for the meeting, and going with the Polish and the Eastern German astronomers. Now, the Eastern German astronomers weren't very talkative. The Polish, on the other hand, were very talkative. And they were talking about everything and political theory and the East and the West and commercialism and that is, the Eastern Germans really got very nervous and very fidgety and very silent. And then I realized there's really a qualitative difference. You know, I'd already seen it before in previous visits to England. That, you know, Europe is different from the U.S.
Well, the closer you get to Russia and the closer you get to that side of it, Eastern Europe.
Yes. And I met a Russian there who I knew a little bit about. Kip Thorne and I re-edited Russian text, relativistic astrophysics. And he was very thankful that Kip and I had done this. Kip is now a Nobel Prize winner, emeritus professor at Caltech, among many other things. And in that environment, at a meeting in Poland, I had the opportunity to meet this Russian guy. And he had been trailing around the conference, but there were all of these short, stocky men with ill-fitting suits following him around. It's sort of like a swarm following him. And Bodon then set up a mushroom picking picnic in the outskirts of Warsaw. And I was invited, and this guy was invited, and everyone else was a Polish astronomer, as far as I know. So I was able to talk to him a little bit. It turns out he designed Joe 2. That is the Russian bomb.
Yeah.
The first bomb they exploded was stolen from Los Alamos. That was Klaus Fuchs' set of plans. And I knew that this guy I knew things about him. So I was talking to him, and he said he thanked me for doing editing on the book. And I said, you know, supernovae are a lot like bombs. Of course, he was the designer of Joe 2. So he smiled. He looked back at me, eye to eye, and said, yes, I know. That was enough said.
Yeah, isn't it interesting that you're there trying to figure out the mysteries of the universe, and you have to do it in a situation where, to the backdrop of all of this, other countries learning this and all this Natasha and Boris bad enough kind of stuff going on in the background.
It was a fascinating time. It was a fascinating
It was also in the way of good collaboration, though, right?
It was.
Yeah.
Because I never would have gotten the chance to meet Zeldovich. He wasn't allowed out of the country. No. You see, he was Jewish. And the Jewish scientists were not as free as the non-Jewish scientists to roam around the world at that time. Nobody in Russia was very free to roam around the world at that time, but especially not a bomb builder who was Jewish.
Right.
So that was a singularly fond memory that I have of those times.
But in your book, I want to get to your book. Well, let's plug your book first. Okay. Supernovae and Nucleosynthesis, an investigation of the history of matter from the Big Bang to the present. It's not really to the present, though, so aren't we starting on some shaky theoretical ground already?
Already.
When did it come out? And then we'll know what the present
1996.
1996. All right. Have you done anything since? No, I'm just kidding.
As a matter of fact, I'm working on, as I was telling you earlier, there's a sort of a appropriate Protestant biblical reference here, which I never intended and would have avoided had I thought about it. But it just occurred to me this morning that the book starts with Genesis, and my current research is now in chaos theory, which is, to my mind, the book of Revelations.
Yep. Let's start with Genesis first. Let's go to Genesis. That's awesome, though. We got to get the chaos theory by the end of this, though. But in your book, you set out to find the basic distribution on the Genesis side, basic distribution of the main types of elements and matter in the universe, or what you call nuclear paleontology, which is the coolest astrophysicist term ever. But you ran into a lot of difficulty with the common ways to measure this. You tried stellar models, meteorites, even cosmic rays, but nailing down an average distribution proved to be a little bit of a bear.
Yes.
And you want to tell us about it? That's most of your book, right? Trying to figure that out, or a chunk of it.
It was very difficult to figure out a working average. What is the general thing that you want to deal with? Well, there can be all sorts of anomalies of different sites, individual characteristics which are not the normal thing.
Outliers.
For example, Lu Alcindor is an outlier in a height distribution. And those things happen in nature. And so the problem is, how do you
determine that's an outlier and not an important point?
Yeah, if you decide that the things you don't understand are all outliers, then it's easy to do theory.
Yeah, there you go. You're just living on the edge, so
right.
to speak.
If that doesn't fit my theory, then it must be an outlier.
Yeah, that's how I would do it.
Well, that's how a lot of politicians do it these days.
Yeah. But isn't also the problem with the distribution, though, that the heavy nuclei can only be made in the sun, and they only come out so often when things explode?
Yes. Stars are an essential part to the whole problem as far as we can tell. Yeah. And we have basically no information other than a few theories about very rare species of elements which might be formed in different places. But almost everything is stars. There's first the Big Bang, which is ill-fated now because of the James Webb Telescope.
Yeah.
It's not so much that the theory is wrong, it is that the theory was too simplistic. And we have known this, or some of us have suspected this for a long time.
I have a thought on this, and you can tell me where I'm way off. That Lindy, the Russian guy who had the rapid inflation and the budding and everything's kind of breaking off and doing different things, couldn't that still explain what's happening to some degree? It's not what we thought.
It could.
Because it wasn't just one big bang. It was all this stuff going on. That's why they're finding galaxies where they shouldn't be and much brighter than they should have.
The wonderful thing about the new infrared results from the Webb telescope are they're showing that we were wrong, which means it's an opportunity to get it right.
Yeah. Well, what part, though, the simple Big Bang and then the Big Crunch, that's what's really out the window. It's just much more complicated than that. There's other factors.
Because it's more complicated and we don't have a viable theory, we don't know.
Yeah. Do you think the Lindy one might be the one that... what's more viable than that? I'm just wondering, because that's...
If I knew, I'd write it up and send it in.
Well, we have another half hour, 45 minutes. We got to figure it out by the end of that. There's no pressure. Right. So... We got the egg timer going. We put a lot of our budget into the egg timer. So, Well, how about Arnett's law? Where does that come in?
Well, in studying the stars, one of the things that became apparent, and this was known by Fred Hoyle and the two Burbages and Willie Fowler back for a long time, and you can see bits of this popping out in the literature. And then finally, in 1957, they published a review paper where they collected a lot of astronomical and nuclear physics data and showed that the elements must have come from the stars. But they didn't get it right. They had it almost right. But the thing that they got wrong was the most abundant element in the universe is hydrogen. And then helium. And then we have this distribution which falls off, but there's a big peak. And the big peak is at iron. And Hoyle and the Burbages and Fowler believe that since it was the most stable element in the region, iron 56 was what was causing this peak seen in atomic spectra. So there's a nuclear physics quirk, which is not so well known, but was is a crucial bit of physics that I don't want to get too deeply into because I could go on and on about it, and that would be inappropriate. Let me just say that there is another element, nickel 56, which is just like, in some sense, iron 56. But the difference is that it has equal numbers of neutrons and protons.
Is this what Stark also found out when he became Iron Man? Does it relate any relation?
Probably.
Yeah, could be.
And it's reverberated in our understanding of the elemental nuclei, atoms. There's some atoms which are more tightly bound than other atoms, depending on how you put them together. And there's some nuclei which are more tightly bound than others, depending on how you put them together.
Bigger boom when you take them apart.
And a bigger boom when you take them apart. In this particular case, the boom comes with the supernova. And it's a signature of an explosive fuel being burned. That is, we're looking at the ashes. They're spread out into space. And if we look at the ashes, we try to figure out how the boom happened.
That's what you were studying.
That's what we're studying. So when you talk about the Star of Bethlehem, that might have been a nova or it might have been a supernova.
Yeah. Oh, really? Wasn't? Okay. Yeah, that's right. It was a star that got much bigger for
It's a star that got much bigger, and we don't have evidence to really definitively put it down that I know of. Right. Someone may have found some. The thing about nickel 56 is because it has equal numbers of neutrons and protons, it can decay by a process which makes those extra protons, or those protons, into neutrons, so that it then has two extra
mass. Yeah,
the mass is exactly the same, but it's flipped the identities of two of those nuclei, the particles in the nuclei, to make the other element.
Right.
And it takes a while for this one to decay into iron 56 instead of nickel 56. And what I discovered was that if you take into account that the star formed explosively and burned its fuel to nickel 56, then that nickel 56 will be distributed in the interstellar medium and it will decay. And before it gets away from its nursery, it will be lighting up the gas around it. And those are, in fact, supernovae, type 1a supernovae, which are used to measure cosmic distances with.
Right. So you figured out how to a signature of the whole
And
thing
it's a
that you could see.
signature with the time scale. You get the time scale by the observer going on the mountain and looking at the supernovae. And they start out being bright for about a week, and then they, over a period of several months, fall off more casually. And that gives you not only does it give you something like a supernova, it gives you the supernova.
Wow. You know, it reminds me, something happened this past year with, they were using quasars when, galaxies were tearing themselves apart in the distance. They'd use quasars as like little light buoys to see when the gravity wave hit,
Yes.
how it got off, how it bounced. Basically, they could watch this lighthouse.
Yes.
And then as soon as it passed, that's almost a variation in a way of just using those.
That leads into a beautiful part of the story, for whom the guy I mentioned, Kip Thorne, got a Nobel Prize.
Wow.
Or he was one of the people.
Well, I could share it with him if I, contributed greatly to the conversation. He can put his name first. This was the big Arnett moment in a way, right? I mean, this was the big one.
Well, it just worked.
No.
If you do the mathematics carefully, you find that you do, in fact, get this sort of very characteristic supernova light curve that people think of, astronomers think of, whenever they talk about supernovae.
Mm-hmm. That's I gotta again. Got to give you some kudos for figuring. We can't do that. No. I'm doing that later. We have a Mad Cujo's. We'll get to that. But shifting, anything you wanted to say to finish that part of it up?
Well, this ties together something you see in the sky, an explosion of a star that happens. These happen sort of. Depends on how deeply you look. But in the galaxy, they happen about once a century. So you have to look pretty large distances to get enough galaxies in your realm of seeing that you see them often. But now people see several hundred.
Wow. And James Webb increased that, I'm sure.
Right. Yeah. And then they show this characteristic light curve. This ties back to something that we see on Earth. For example, the Hawaiian Islands. If you look at the Hawaiian Islands, you'll probably see a video of the lava flow. Or you may be lucky enough to go there and see the lava flow, hopefully not too close. Mm-hmm. This lava is molten iron. This molten iron was originally much more prosaic, but it had a part of its history as nickel 56 that was seen in the supernova.
Awesome. Yep, that's pretty awesome.
So you see there's a connection here that I still find mind-boggling.
The distribution of stuff across the whole universe, basically.
The distribution of stuff across. How the hell did it get in this way?
And bubble up in Hawaii.
Bubble up in Hawaii.
Yeah.
And come in the form of iron meteorites, which fall on the Earth all the time. And it's presumably part of the other planets.
And more to come.
To come.
I want to shift gears and totally, because this has been a nice interview so far.
Just you wait.
I want to attack physics at the core here. Shifting gears, here's Abraham Maslow, and he said, and this is of course a psychologist, but he said, the perpetual coping with seeming paradoxes, contradictions, and vagueness, and the occasional collapse around my ears of long-established, firmly believed in, and seemingly unassailable laws of psychology. That's what he heard throughout the hallways when he was doing his thing back in the day, which isn't a surprise for psychology. As someone who studied psychology a little bit, I'm not shocked by that. What I am shocked by is that in 2024, we can kind of say the same thing about physics, post-Newton physics. I will.
Yeah, there's a difference here, but it's fairly subtle. That is, and I remember, especially when I was an undergraduate, reading a lot of psychology, being interested in the extent to which you could use experiment to figure out how the mind really works. And the subtle difference is that physics tends to be more cumulative.
Building off the math and the data.
It's more of a hard science.
But even string theory it's building on its own theory. It is kind of going off on this direction that could.
I'm talking about run-of-the-mill physics.
Well, I'm talking post-Newton.
Post-Newton string theory didn't really start until I was already in graduate school.
Yeah. It seems to me that at the heart of it, there's a lot of going on, not just with the cosmology, not just with Big Bang, Big Crunch. It just seems like everything's shaking a little bit right now.
Well, it's always been shaking. Newton was a mover and a shaker.
Shook that apple tree down.
Yeah,
don't forget Galileo. He gave him the idea about inertia. But yeah, and if you go beyond to the next century, you start developing electromagnetism. And a bit further, you start seeing discussions of light, and then thermodynamics, and then chemistry and geology. And there's an underlying solid bit that keeps growing. Now,
you only fall back so far, is what you're saying.
You only fall, it's 2 steps forward and 1 step back.
Right.
So you keep going forward in total. And the wonderful thing is there are a lot of things out there that we observe that we don't understand.
And the James Webb is really bringing that home right now.
And right now, the name of the game is to figure out, can you imagine in your puny little ape-like brain what the universe is really doing?
Yeah. That leads to my next question, but go ahead.
Well, for the ape-like brain, one of the things that is come out of doing the book was the origin of oxygen and the carbon, which are 2 of the most important organic things. And they're formed by a certain kind of star, a massive star, and during stage of its evolution, which is really strange, which is cooled not by light. Light takes too long to filter out of these stars. It can't cool them, but neutrinos can.
But you're saying, so we have an oxygen-nitrogen atmosphere in a planet that this star, our sun, could not produce.
Our sun could not produce it, but Rigel, which is one of the stars in Orion, could and probably is.
That's, again, distribution is everything.
Yes.
Or we wouldn't be here talking about distribution.
That's right. And the question that springs to my mind is that we have this distribution of elements which is spread throughout the galaxy and the universe, other galaxies. So what are the odds that this is the only place that people would be talking as we are?
Right, especially because Rigel is very far, and we're here,
Right.
and we got enough of the oxygen to make this an inhabitable planet. And obviously, if you're closer to Rigel, it might be more oxygen. Who knows?
And I think it's one of the hard things to do is to assimilate distances in astronomy. Mm-hmm. Rigel is really very far.
It just because it's bigger. It looks like
It's
the other
just
stars.
big.
It's bigger,
No, Rigel is a big
Monster,
star,
yeah.
but it's a far star.
Right. I get it.
And if you start saying, well, it's not nearly as far as these other stars, well, no, it's not. All the stars are far apart.
Yeah.
The nearest stars are the Centauri, Alpha Centauri, which is a group of several stars, actually. Mm-hmm. And I think Proxima Centauri is still over 4 light years away. And our space probes are just now getting out of the immediate environment of the sun. Mm-hmm. And it will be literally centuries before they get anywhere.
We did an episode on that, and Jeremy could argue with you that later. So that'll be maybe coming soon.
I'm not going to argue that. That was all correct.
Well, I'm just saying though that he's come up. He's kind of discussed some of the theoretical ways to get places faster in one of our recent episodes, which was really cool. So just FYI.
Get to that at the end.
Yeah, we'll get to that when we start talking about our crazy theories. Where does dark matter fit into the distribution?
Dark matter
the confusion
is something that we don't understand, where we clothe our ignorance in a convenient box.
It's like junk DNA. It's the same idea as like, we don't know what it is.
Yes.
So it's junk DNA. But dark matter had to have factored into the whole distribution of.
Yeah. There has to be something like it.
Yeah.
And it's got those characteristics that we need to patch up our theory.
And you patched up some of your distribution theories with
Right.
dark matter. Yeah. Fifth force in physics. Coming soon? If so, what is it?
Dark matter.
Yeah, well, you think that's so within the energy, dark energy is the fifth force then.
What is dark matter and dark energy?
Yeah.
They are certain inconsistencies in the current theoretical framework, but we don't know what they really are.
Right.
And it may turn out next year, hopefully. I'd prefer it to be next year. I'm already 83, so I'm not expecting to live too many more centuries at this point. We may know what those forces are, or we may not. They'll be at the level of a Nobel Prize discovery.
Yeah. There's a lot. That's the biggest opening in physics right now, I would imagine.
Yes. Well, there are many different ones, and some of them may be related in ways that we don't know.
Yeah.
So when you say, well, the biggest is, no, we've got so many things that we don't know. After all, we're mere hominids. Mm-hmm. Yeah. We should be humble hominids.
Well, you saved physics, though, because I tried to trash it, and thanks for kind of saving that a little bit. Before we get away from James Webb, and I just want to do a few in the newses, but has this telescope found proof of a world resting on the back of 4 sacred elephants who were they themselves resting on the back of a giant tortoise?
It depends on what their names were.
Well, Atuin, great Atuin was the turtle, and I would have to pick out one of my Pratchett books to find out. But anyway, in the news, I want to shift to in the news. Do we have an in the news bumper? We have bumpers for things.
This is an MLT Breaking News Break.
They recently teleported energy for the first time. Like one particle kind of skipped across the quantum foam a little bit, and they're calling it teleportation. I'm guessing you'd have to kind of toss that on the side, the flat side, so it kind of gets a good skip. I don't know.
I don't know. Maybe the flat earthers had something.
Yeah, well, there you go. But I think, but more importantly, I think if we invent the teleporter, I think an exact duplicate, your doppelganger, comes out the other side, not you. I mean, what do you think about that? Like if Star Trek teleporter, you get in, you come out. I think there's an exact duplicate on another planet. What makes you think that fifth force didn't come with you, Boris?
Well, now you're talking about things that should not be taken so lightly.
Mm-hmm. You mean Star Trek references?
Star Trek references.
All right, well, just moving on then.
That's one of my favorite shows.
And physicists today are on the verge of knowing how to get people out of timeshares, which I think is important as well.
Yes.
Yeah.
Time sharing or time shifting?
What's timeshares? I mean,
both. I know what timeshares are too. I've been a computer jock for too many years now.
Well, then tell us about time shifting.
Time shifting is simply a term. This gets us too far into too many weeds of science speculation that probably don't lead anywhere.
Okay, well, here back to the broken universe then. Let's get on a better topic.
Yeah.
Michio Kaku says in Parallel Worlds, today we see that the universe is horribly broken. It is not uniform or symmetrical at all, but consists of jagged mountain ranges, volcanoes, hurricanes, rocky asteroids, and exploding stars, without any coherent unity. Moreover, we also see the four fundamental forces without any relationship to each other. But the reason why the universe is so broken is that it's quite old and quite cold. So after seeing the condition of the universe post-Big Bang, does that make God a terrorist or a freedom fighter?
I think this is, I wish it were a more poetic attempt to toss a Molotov cocktail.
Mm-hmm. So you do feel that's you're more on
I
the
would be
terror
happy
side.
to argue with him.
Yeah. Oh, so you think it's more eloquent and more symmetrical and more beautiful?
No, I don't know why it has to be symmetrical.
Oh, okay. Well, symmetry and beauty are often connected.
That's Chandrasekhar wrote a book about symmetry and beauty.
Right. So, and Michio, by the way, and I know Jeremy's a big fan, but our crew might know him from Ancient Aliens. He's kind of a regular.
Yes.
And he built a particle accelerator in high school, which was functional, that he kind of used. That's a true story. But I wasn't building particle accelerators till much later in my life.
No, so. I went into theory rather than that. I sort of stopped in high school. I was trying to build a computer instead of an accelerator.
There you go.
And a poor Kentucky farm boy could not buy a sufficient number of relays and switches and so on to build a reasonable computer. But I designed it.
Well, that's still that's impressive to do those kinds of things compared to what Jeremy and I were doing in high school, which was smashing neurons, not atoms. But I do have this other cool moment in the news. Scientists want to use massive lasers to melt roads into the moon. That's from MSN.com. Now, does this get mankind one step closer to sharks with friggin' lasers on their heads?
I don't think you realize how close that comes to. One of the things that I did when I was consulting was to consult with the Lawrence Livermore Lab, where they build lasers to explore controlled nuclear fusion.
And fusion keeps coming up in the news that they have it, they don't have it. We've got something that looks like it. It's small, but they can't repeat it. They do these little things. They're trying to harness these.
They've gotten to the point where they produce more energy than it takes to make the laser run.
Right. Right. So
and which is quite an accomplishment
in itself, yes.
in
It's a
itself.
start, yeah.
But it is not the same as having,
Functionality,
it's not an ever-ready battery.
Right. It's a never-ready battery at this point.
Yes.
Yeah.
Let me jump in for a second here. You did say they were getting more energy out of the lasers than they were putting in to generate them. Does that break any of Einstein's rules if they can make that really stick and keep going like a perpetual motion machine?
No.
Einstein
that's
still
not
holds
a
up.
perpetual motion machine.
Oh, I guess it's creating energy, I guess would be more to the point.
It's switching the form of energy. You see, what it's doing is taking nuclear energy with the fuel and generating sufficient heat that the ultimate is like burning a fire. So instead of creating energy, it's changing energy from one state to another state, which is what they mean by power production.
Okay. Thank you for that clarification. I appreciate it. I thought I was going to be able to stop the egg timer there for a second, but Einstein still holds up, Moz.
We're going to keep trying. But a couple of quick things before we move to the next segment, though. But original Scooby-Doo episodes. How do they create all those really scary scenes with just curtains, pulley ropes, and a fog machine? I mean, you're an astrophysicist.
Imagination.
Oh, imagination. That seems like a cop-out.
Yeah, it is.
Original thing with James Arnett or the John Carpenter 1982 version?
I don't remember.
Wow. You don't remember the movies? Or you don't remember what you like better?
I am getting too old to really remember all that well.
Okay. Well,
I couldn't admit this as an undergraduate, but now I'm professor emeritus, and I'm saying, "Oh hell, I don't remember that."
Well, we'll try one more. We'll try one more.
If I were a politician, I could say it never happened.
I'll try one more. Omega Man, and that was with Charlton Heston. Last Man on Earth, which was with Vincent Price, or I Am Legend with Will Smith.
Oh, I think Omega Man.
Nice. Charlton, we went old school. I'm all right with that. Thank you. Before we leave, anything from the sane physics world before we get into the insane, what we like to call our Ahu Guano theories.
Oh no, here it comes. Quick, to the batshit signal.
The sort of physics that I do is replete with uncertainty. And we're wrong often. So it's really a victory when we're not wrong.
Well, a lot of the math has worked out over you. That's what we read about. That's what we learn about.
That's right.
And some of it is so established. Like you said, it's that 2 steps forward, 1 step back. But there's a firmer foundation than...
Right, because if you've gotten that 2 steps forward, that 1 step that you don't lose can still be used in the future. And it's cumulative.
Yeah.
You don't know which bits are going to survive.
It's a domino in the wrong direction sometimes.
Sometimes.
I feel that
chaos theory.
Well, string theory could be one of those dominoes, right?
I like chaos theory better.
All right. Well, we will get to that. But before we leave physics, the classic physics and classic physicists, Sagan, Neil deGrasse Tyson, run into some of those guys along the way.
You're talking about one of my buddies.
Which one?
Neil deGrasse Tyson.
Wow.
And Carl Sagan.
Nice. So what, do you have some stories from beating each other up in the old neighborhood?
I met Carl Sagan and the Goddard Institute for Space Studies in Morningside Heights, because he would come down to Cornell, and at that time there were a lot of things going on, being planned in planetary science. And I had lunch with him several times. I was one of the many graduate students who hung around there.
His favorite beer?
I don't know, because the cafeteria wasn't serving beer in those days.
Dang. And Neil deGrasse?
This was the 60s.
So different era, you got Neil deGrasse Tyson, and where'd you run into him?
I ran into him on the Isle of Elba. He was introduced to me by Alvio Renzini, and he was a graduate student at Columbia at the time. Then I was a faculty member.
And you did, because this is part of a conversation we had once before, did Neil deGrasse Tyson cause some trouble out there in Alba Island?
He was well behaved.
That's not a denial. That is not a denial. We didn't hear anything about, in Dr. Arnett's defense, we didn't hear anything, but there was a hint of an illusion of perhaps some shenanigans, I guess would be the word.
I would say that I suspect Neil has an acute sense of humor.
I know he does. He's made some pretty funny jokes over the years. So, well, cool. So as we get into the mad freewheeling theories, now I guess we can do these are our Ahu Guano theories, our batshit theories of the week.
Oh no, here it comes! Quick, to the batshit signal.
We get a little bit off into more theoretical stuff, which is still your area. And I want to start this because this is where the right-brainers get to play a little bit too. And this is Einstein once said, the intuitive mind is...
Did you mean right in the sense of
correct?
Orientation or correct?
Both, yes. The intuitive mind is a sacred gift, and the rational mind is a faithful servant. We've created a society that honors the servant and has forgotten the gift. So qualitative, quantitative, right brain, left brain. We talk a lot about weird stuff and, places where people seem to see monsters. And we call non-believers, by the way, on this podcast, scully muggles. I'm wondering where you fit on the spectrum of the weird and the paranormal. Just basically, where do you stand on that stuff? We got it took this is the longest we've ever gone without an exasperated sigh and a smart person ever. So we're pretty proud of ourselves. Where's the egg timer for that? So we didn't get Einstein. Let's at least check the
55 minutes.
There we go. 55 minutes before an exasperated sigh. You're a lucky guy.
I remember spending a lot of time as an undergraduate reading translation of sacred Hindu texts.
Nice.
And trying to figure out Zen Buddhism.
Well, there's a lot of overlap with the Upanishads and a bunch of those old texts and what you're doing. There does seem to be a core connection between some of their origin myth and what we're seeing in physics.
If you go as far as you can with the data that you can, and you still haven't solved your question, then you come up with an answer. And that depends on your imagination and, what data you do have.
You go with what you have.
You go with what you have. The difference is, in science, what you do is you then tear it down.
Right. Reconstruct it, see what you get.
Yes.
I'm not a huge Scully muggle, and I believe some things are weird in this universe we're in. But Demon Haunted World by Carl Sagan was a brilliant book, and it actually was the best from the Scully muggle side of just debunking. And it's because he took the time to really look at least what people were experiencing. the Dawkins of the world just kind of say, it's not worth my time. And Carl Sagan really looked.
Yes.
And it was an impressive book, and he did a wonderful job. And I always say, putting that book down, yeah, Carl, but a lot of people were seeing all these themes that kept coming up. What is that about? And again, it might be more in the realm of psychology, but it's still interesting. And I got to give him a lot of credit for doing kind of a great job with that effort. So your old friend,
yes,
who, and hopefully Cornell has some beer by now. I mean, let's hope things have gotten one step forward, two steps back.
Wisconsin did better.
That I don't doubt. Was it Madison? Where did you?
Madison.
Yeah, there you go. I've been to that town a couple times. But here's a weird one. So in a conversation with Jeremy, he told me that the gluon or muon looks very similar to a yin-yang symbol of Taoism. So I was thinking, when I heard this, could the yin-yang also be a two-dimensional representation of an Einstein-Rosen bridge, but one that begins and ends within the same universe? So the dots are opposite. The bridge itself, now keep in mind, because the opposite is sometimes called the white hole, and the bridge would be that tube that connects the two, and you kind of get what looks like a yin and yang from an Einstein-Rosen bridge, depending on how you would represent it.
Wow. When we have...
we got a wow out of the non-astrophysicist.
When we have limited understanding, we do the best with what we can.
Well, there you go. And then we have a lot of limited understanding to go around here. But I was even thinking...
I was going to say that you beat me.
Stop the egg timer. Stop the egg timer. No, but the...
58 and a half minutes.
There you go. We knew we'd stump him. Well, we knew what was going to happen. But in a way, it's like the muon... What if the muon, taking it a step further, if the muon was the small galaxy itself with an Einstein-Rosen bridge in the same... like that, what if the muon itself is a galaxy
I remember a quote, an attributed quote. I did not hear this directly, but I have read that when Fermi first heard about the discovery of the muon, his comment was, "Who ordered that?"
Yeah, because particle physics gets so bizarre. We're going to get to that a little bit today, and actually I'll probably save that for one of my other my other question. But how much marijuana do you think Jeremy and I would have to smoke to solve all the riddles of the universe? I mean, you're an astrophysicist.
All of it.
I think I'm not a sufficiently good judge of your bodily capacities.
I'm just going to say all of it.
Yeah.
I suspect so.
Depends on the distribution of dispensaries across Tucson right now, probably what it would be. But we have these packets bouncing around, these collapsing, this entangledness. Basically, we have it's a mess, and even particle. When you try to break down a piece of that, it gets more and more complicated each layer you get when you talk about particle physics.
Yeah, but is that due to what you're discovering are the limitations of your mind in assimilating the data?
We're going to get to that. Because that's exactly what we're going to talk about in a moment. Here's one time more Michio Kaku. When we apply the quantum theory to the universe, we are then forced to admit the possibility that the universe exists simultaneously in many states. In other words, once we open the door to applying quantum fluctuations to the universe, we are almost forced to admit the possibility of parallel universes. It seems we have no choice.
But this is about limitations of his brain. That's what we're forced. He is forced. It doesn't mean all of us are forced.
But isn't that a way, because string theory was an eloquent way of, again, using dark matter to...
It might be. It may turn out that he's exactly right.
But I think...
But he doesn't know, and we don't know.
Well, I try to shift it into, like, I like Bohm, David Bohm's work, and that whole fluctuating pilot waves. And this is from Bohm here. The overlapping of these waves generates what appears to us as particles, which constitute the explicate order. Even space and time might be manifestations of a deeper implicate order, according to Bohm. I guess he didn't say that. Someone else said that about Bohm. I'll have to get that in the show notes and figure that one out.
I came across Bohm as an undergraduate at the University of Kentucky, or one of my professors teaching an experimental course in quantum mechanics, which was not part of the general curriculum. He was introducing this new thing, which was all...
So you came across Bohm's books or Bohm?
Bohm's books.
Okay,
Not,
there you go.
No. Bohm's thought.
It's thoughts in book form.
In book form. Oh, no, I was at the University of Kentucky. We didn't...
Yeah, he wasn't. Dave Bohm wasn't hanging out. He was hanging out Cornell.
I didn't even have a passport then. I've gotten a passport since, but I didn't have a passport at the time.
But that underlying piece, the quantum foam, the morphic resonance with Sheldrake, implicate order, which is Bohm's view, underlying reality, any hints of that? I know we're not there yet. This is a very theoretical piece of it, but it may have to do, like you said, with dark matter, maybe really the underlying
Could be.
Piece of this.
I like to think I'm agnostic about this.
I got you. We get to that point, right? But M theory starts to be even more, because M stands for membrane, and it seems to be more like a drum, a shaman's drum. So this is going to be my last little theory piece, and I have to say, I apologize because I'd rather listen to him talk, but I have to read a few of these just to make my case for this. The MLT listeners are all groaning, and then the astrophysicist, it's an even bigger groan. It's audible. But Christina Pratt from Encyclopedia of Shamanism, to start us off, both quantum physicists and shamans alter reality, though in different ways and from different points of view. Important point to make here is that there can be no objective reality in the scientific or spiritual realms of our universe. The observer always affects that which is observed. Both scientists and shamans interpret their experiences subjectively. There's no other way any of us can view things. So quantum waves exist for the physical in the same way that spirits exist for the shaman. The spirits the shaman sees are also coherent energy patterns within a greater field of energy. However, unlike the physicist who believes in his or her theories of the invisible world, this shaman experiences the invisible world. And there is an answer now that comes from shamanism again on the Hawaiian side. We'll read this one, then we'll discuss. And this is going to be again from Encyclopedia of Shamanism, by the way, different section. The Aka, A-K-A, according to Hawaiian shamans, see, we're back to Hawaii with, iron 56 bubbling up through the earth. According to Hawaiian shamans, the stuff of which everything in the universe is created and connected, a vast web of Aka threads connects all things. These connections can be created with thoughts or intention, aka threads and receptacles and or conductors of mana. And that's kind of like maybe Bohm's implicate waves, maybe. But they can be activated with attention and sustained concentration. The Hawaiian kahuna, the shaman, manifests change and affects the desired outcome by establishing Aka threads and working through those connections. The Hawaiians perceived of a level of action where everything is connected through Aka threads. This is a second level of existence beyond the physical reality that includes a subjective level of thoughts, emotions, and psychic phenomenon. Maybe Aka threads is what's underlying reality. This is where you're agnostic, I understand.
I'm agnostic.
Yeah. Any thoughts on that?
It strikes me, and this may be completely unobvious from this discussion, but I actually have some humility. And I think it would be presumptuous as a weak little hominid to think that I'm understanding all these great, big, enormous things. There's just a few things you can do. That's the reason I was attracted by physics.
Indian Vedic, we went back and dove into some of the old literature too.
Yeah.
So it's kind of that, and that's kind of what we're bringing together here. I got one more quote, and then I'm going to bring it home with what I'm thinking here. This is from Daniel Pinchbeck, by the way, Turn of Quetzalcoatl. I realized that apprehending the pattern of occult thought was more important than adhering to the details of any particular system. The occult vision offers a way of conceiving reality that is closer to art, or to the theme and variations of music than science. What if at the higher levels of meaning consciousness, it's like hyperspace in which each point is equidistant from the other, where the center is everywhere and the circumference is nowhere? He then quotes William Irwin Thompson's passages about Earth. The mythologies of the occult seem like Baroque music. There is an overall similar quality of sound and movement, but upon examination, each piece of music is unique. Vivaldi and Scarlatti are similar and different. The movement away from the linear and the dualistic thought of one-dimensional man. It opens this is back to Pinchbeck, opens on multivalent meanings of mytho-poetical modalities, requiring equanimity and a firm grounding in reality, a difficult balance to strike. So it seems
male bovine guana.
Ahuguano theory to you, sir.
Bullshit, man. Bullshit.
But what I'm saying is, and this is back to what we were talking about with breaking up those particles and reading Parallel Worlds from Michio Kaku, it sounds like you're actually breaking up the wave, and that's what you're not looking at the whole thing. And he makes that connection between notes.
One of the problems here is a lack of mathematical generality in the thought pattern.
I'm saying
it's
M theory.
Non-linear.
Okay, but
it's multidimensional.
It's
this stuff. He's talking about one dimension. He's doing a linear extrapolation. The universe is more complicated than that.
But it's what reminded me of these things in reading Parallel Worlds is that when you smash an atom, you collapse a wave. It's so complicated, but if you put it all together, it's because we're squishing a bug and then you're looking at the pieces. But the whole thing is a wave, which is a note. And the membrane, which is M theory, which is string theory, sounds more like a drum. So it does sound like there's string, there's drums, there's music.
Particle wave duality.
Particle wave duality. Yeah, when it comes to
that 19 and 20s.
So this is old stuff, not new.
Oppenheimer.
He was squishing some bugs, yeah.
Yeah. This is what Oppenheimer was doing before he got involved in the Manhattan Project.
And was he doing something similar in what way? Like he was trying, because I feel like we're just
wave particle duality.
But I feel like we're coming at it from left brain and right brain, but it's saying the same thing. I guess that's my point. They start to sound similar.
Right, but it's sort of old hat, though.
Right. So I'm coming up with 1920s. I'm up to the 1920s.
Right.
Is what you're saying.
That's what I'm saying.
Okay.
Now, that doesn't mean it wasn't done in the 2020s.
Yeah.
We keep,
coming back.
2 steps forward, one step
back.
Yeah.
I just hear these echoes when
and
I
also, we have a finite lifetime.
Well, not for long. I mean, they're going to do I saw Futurama where our heads are going to be in fish tanks, and then we're going to be able to move around on robots.
I forgot about that.
See, it's not just Star Trek.
Would you like to be in a fish, your head to be in a fish?
Well, they do the little Tetra they feed you at different parts of the cartoon. So, anyway, that's where I want to hand it over to a couple of Jeremy questions, and then we're going to start moving towards wrap-up.
Okay.
But thank you so much.
I have a couple of things I've talked about on the podcast relating to potential alien craft, UFOs, UAPs, and stuff.
Oh.
So
this was something I was thinking I wanted to talk to you guys about.
Oh, cool. Okay. I have 2 things specifically that I want to talk about that I've talked about kind of extensively in the podcast so far. One is the inertial mass reduction device being built by the U.S. Navy and what the implications of that might be. Can I read you the breakdown on what that is and get your response to that?
Okay. My initial response is skepticism.
Okay. Well, this is a patented thing. They're building it. There's R&D. They just launched supposedly some sort of working prototype into space and attached it to a satellite. In October, I think it launched. I have all the stuff I can show you after if you want to see the links.
Okay, I'm totally ignorant of this.
Okay. Well, this is from the Navy's FOIA page. These are FOIA documents that have been released on the PAX 205 project. And it's all about building what they're calling an inertial mass reduction device. So I'm going to read you a couple paragraphs.
Okay. I would say that's like saying 2 + 2 = 25.
Oh, wow. Okay. Well, let me read this and see if it's just more male bovine guano. Or...
As I said, I don't know anything about it. And
Okay.
it might be perfectly legitimate. I would...
Well, this is kind of the theory behind it.
Okay.
Let me read you these couple paragraphs and we'll see where it goes. So it says, it is possible to reduce the inertial mass and hence the gravitational mass of a system object in motion by an abrupt perturbation of the nonlinear background of local spacetime, equivalent to an accelerated excursion far from thermodynamic equilibrium, analogous with symmetry breaking induced by abrupt changes of state phase transitions. The physical mechanism which drives this diminution in inertial mass is based on the negative pressure, hence repulsive gravity, exhibited by the polarized local vacuum energy state in the close proximity of the system/object in question. Inertial mass reduction can be achieved via manipulation of quantum field fluctuations in the local vacuum energy state in the immediate proximity of the object/system. Therefore, it is possible to reduce an air vehicle's/spacecraft's inertia, that is, its resistance to motion/acceleration, by polarizing the vacuum in the close proximity of the moving vehicle. Polarization of the local vacuum is analogous to manipulation/modification of the local space-time topological lattice energy density. As a result, extreme speeds can be achieved. And they're basically talking about breaking space-time.
Okay, the last phrase would be the only one I would disagree with.
Oh, okay.
Therefore, extreme speeds can be achieved.
So you don't think that inherently means we could travel faster than light?
Let's prove it.
Okay.
That's...
So, but that all sounded right to you up till that last bit. You're not going to just give them the extreme speed
I wouldn't
thing.
say that it sounded right, but I wouldn't say that it could happen.
There you go.
Because they're playing games at the edges of what we know. And maybe those games are correct. Maybe they're not. Data. We need data.
Fair enough. Yeah, they're just starting to actually test it.
We are playing games with the edge of what we know, and that's kind of what we're doing here. So thanks for bringing that. We can use that as a tagline.
That was actually a more supportive response than I expected for that, because I did a whole big thing on that. So I'm glad that at least it mostly holds up. It's just lacking in the proof at the end.
Can you make a bovine joke about him, though, please? Bovine, please.
It would be only... I got one more question. So,
don't forget, I grew up on a Kentucky farm, so bovine jokes, watch out.
It gets pretty deep.
Yeah, it gets piled high.
one other thing that's really kind of my own theory at this point, but was backed up by a recent article that we mentioned in an old business section, I think, recently, that these UAP crafts that we've seen, some of them seem to be potentially hypercubic, like hyperdimensional in nature. And I have hypothesized the potential of Tesseractian craft. And there was a news story recently, actually, where one of these whistleblowers going before Congress and everything said that they had actually recovered a crashed craft that was, and the quote they put in the article was, it was bigger on the inside, which would kind of play into that. Just potentially, theoretically, again, we're in the Ahul Guano section at this point, so let it rip either way. But do you think the potential, just the potential existence of these things could be a thing?
I have a lot of friends who think of themselves as being members of the reporting community. And I dearly love my friends, but I can believe that my friends might have gotten the story wrong.
There's my male bovine guano right there, Moz. There's my bullshit response right there. So we didn't break Einstein. We're almost an hour and 20 minutes into this thing, man. Oh, well, I'm going to give it back to you, Moz. I've made enough fool out of myself, I think, for one day.
One of the things we like to do here is give to the person who, most contributed to this. And because it was an interview with you, by default, you kind of get this. It is an honorary treat, though, called the MLT Mad Cujos Award for this show.
Damn boy!
And since you've received our Mad Cujos Award now, will you be updating the Wikipedia page, or should we? Or
Of course.
Where can we get your books? You should probably plug that before we...
Princeton University Press. I'm not sure they're still stocking it.
Mm-hmm. Well, he didn't do his homework, apparently, but that's, we didn't either. So you're in the right club. But we would also love to keep the lines of communication open. If I have more important ideas about, say, like neutron stars and chupacabra migration, we would love to get, which I'm currently mapping, by the way, but we'd love to get your opinion on some other Scooby-Doo questions that might come up. And if you have anyone that you could recommend to come on next, since you know all these cool people, right? I have an idea. What if you tell Neil deGrasse Tyson, if he doesn't do this podcast, you're going to say what happened in Alba?
I suspect that Neil will have conveniently forgotten about our meeting in Elba.
All right, touche, sir, touche. I got one last question for you, and this is one, I really mean this to be like a Einstein-Rosenbridge here thing. Basically, to kind of keep things going for the next one, we're going to give you a question you don't have to answer today. What would happen if Maxwell's demon used quantum foam to shave Schrodinger's cat with Occam's razor? You don't have to answer that now.
Hell would break loose. Have you ever tried to herd cats?
Yeah, that would be, that's how Oppenheimer started with a cat, right? And
yes.
He extrapolated from there. It was so basically, I don't know. A lot more to talk about next time.
Yes.
We weren't supposed to jump out. It was supposed to be the bridge, which looks like a yin and yang, by the way. So a muon. So thank you very much. We really do, all kidding aside, really appreciate you coming on. And it's been an awesome experience. We're very excited. You're almost as prestigious as when we interviewed Jeremy's roommate a couple of months ago. So, you're in a kind of a elite club.
Thank you very much for listening to my rantings.
Yeah, this definitely brought us to a new level in our interview, so we really do appreciate you coming on, Dr. Arnett. Much appreciated.
We're not sure if it's up or down, but it's a new level. One step forward, two steps back.
We try to keep the amplitude large, even if we don't know the sign.
Yeah. We'll end on that. Thanks again, Dr. Arnett. Boy, you give an astrophysicist an inch and he takes a light year, Jeremy.
Yeah, they're good like that. They're good like that.
No, we had a lot of fun. Dr. Arnett's passion really came through at times. I feel like he
his
does.
sense of humor, too.
Yeah, we laughed at stuff later that he said, which is kind of usually what happens with me, but he kind of stole my thunder on this one.
He got the biggest laughs in that episode, I think.
Yeah, he did a very nice job. The one thought I'd kind of get stuff done a little bit because he kind of male bovine guanoed me. Was that first?
Case in point, yeah.
Was that first? You have this wave, but when you collapse it, you squish it like a bug. All those pieces are now in particle form. They become really complex atomic puzzles with quarks and strange particles. The complexity becomes our particle physics.
Right.
Together, though, sounds more like a musical note. And I just feel like some of the shamanic stuff that we talk about, some of the contemplatives, some of the Vedic stuff he talked about,
right?
It does. Sometimes they can agree and things point in the same direction.
Sure.
That's all.
It's taking a leap.
Yeah.
You can't always get people to jump with you when you're taking a leap like that.
Yeah, one of the things I should have done is he noticeably bristled when I said occult. And at that last thing. And it's like the Robert Schoch with the top of the Sphinx. You don't show them that initially. You just show them the rocks. And
you gotta ease them into it. Ease them into it.
Yeah. But that's ultimately what I was trying to get at with mystics and shamans and science. But there's a lot of outward today, objective realm outlooking, and that's from the James Webb telescope we kept using as an example. But I think Jung's descent into the unconscious, some of the stuff we've been talking about, some of the secret teachers, I think there's monsters there, and I think we're going to find them here in MLT. That's
there you go.
Our promise to you.
Hell
and I wanted to end on something weird. They named that telescope we kept talking about, the James E. Webb, after the second NASA administrator. But there's a historian just named James Webb who studied the occult. And he complained the occult is...
way.
I'm not making this up. Just historian James Webb.
Synchronicity, dude.
Well, I'm saying there's the outward look, which was James E. Webb. The inward look was James Webb. And one of the things he said was that the occult is a rejected body of knowledge. And I'm just saying, like, back to the Einstein quote that I had said, that basically we're ignoring the gift. We're looking at one part of it, not the other. We need to kind of look at both. And I think if we get these James Webb on the same page, same wiki page.
Yeah, we need to get those two James Webbs synchronized in thinking about all that stuff at the same time in a real way. And then we might find some real answers here, man.
Exactly.
That's brilliant.
Yeah. Thank you, sir.
And speaking of which, I am hoping that at some point we can get Dr. Arnett back on to talk strictly about chaos theory, because that's his new thing that he's into. And we didn't get a chance to get to that.
Yeah.
Because, he knew how long a lecture is, and he nailed it.
But he also kind of said, as long as we get to chaos theory, and we chaos theoried him, though. We kind
of did at the end. It was very chaotic at the end. I will give it that with our theories.
Yeah.
But yeah, hopefully, we don't want to repeat ourselves too frequently, but hopefully maybe sometime in season 2 we can have him back on chaos theory.
Yeah.
Keep our fingers crossed on that one.
Hey, maybe we should end on Jack Webb from Dragnet. Like, just the facts, ma'am, or what else did he say? You remember Dragnet? No?
Not really. I mean, kind of. Joe Friday. Right?
Joe Friday.
The Tom Hanks and Dan Aykroyd movie.
No, it was with Jack Webb. But anyway.
We should talk about TV with my dad. Some reason you guys have the same TV experience.
Rotten kids. Get off my lawn.
Yeah.
That's what I got.
But, okay. Well, let's get out of here, man. Hopefully everybody enjoyed that interview as much as we did. Dr. Arnett, thank you very much again. We will see you next week on the Monster Lore Tour. Till then, have a good one, listener.
Neil, please, if you don't come and interview with these guys, they're going to keep making me talk forever. And I don't have forever. The universe comes to an end.